This video is going to show you how to work problem 2 from homework 2. So in this homework problem, we've been given a file orders.save that has the complete list of all the orders from some catalog company. And we're told that we can regard this as a very large sample of all orders. Now, one thing that I'd like to just mention before we get into the questions itself is that this homework exercise is based off of a problem that you've already done. So if you go to actually, let's see, it's a chapter 8 problem, and it's from Siegel 8.24. And you're told that the typical incoming telephone call to your catalog sales force is such and such. I would encourage you to go watch this video again because a lot of the parts are the same, but not all of them. All right, so the correct answer to this first question, which was, based only on this information, can you find the probability that a single incoming call will result in an order more than $40? Why or why not? The answer was to this one was no, because you don't have normality. Now let's go back to the problem that we're discussing. So let's go read through the parts here. So estimate the probability that a single order is more than 40 euros. Briefly describe how you arrive this estimate. So let's go over to the data and I'll show you what it looks like. By the way, to find the data, go to Blackboard, then go to the Baboogle site, and it's this file right here, orders.save data for computer homework 2. All right, so let's start by looking at the distribution. So I'm going to go up to Analyze Descriptives, and then let's go down to Explore. And I'll bring in this order amount variable. Let's go up to Plots. I'm going to turn off the stem and leaf and turn on the histogram. Go ahead, OK. And that should do it. Go ahead, OK. And SPSS will take a second. There's going to be a box plot that has a whole lot of outliers in it. Now, let's start out with our histogram. And so what we see is that it is very right skewed with very many outliers. And if you go back to your descriptives, the skewness is 5. Remember, a normal distribution has a skewness of 0. The kurtosis is 51. Remember, kurtosis of normal distribution is 0. So both of those statistics tell us that this distribution is nowhere near normal. You look at your box plot, it's extremely right skewed with many outliers. So what we've discovered so far is that the population distribution is nowhere near being normal. Let's go over to Excel and take some notes. So the population distribution is right skewed with outliers. It is not normal. Now, we have to find the probability that a single order is more than 40 euros. So I'm going to get rid of my box plot since it's so... Actually, I got rid of a lot of plots. To actually answer that question, now that we have raw data, we can use a frequency distribution. So let's go over to Analyze, Descriptives, and Frequencies. Bring a mount in, and go ahead, OK. And so what you'll see, if we use the cumulative percent column, we're going to have to scroll down a long time until we get to 40 euros. So here's 40 euros. If we go over to the cumulative column indicates that 69.3% of our sample has a an order size of 40 euros or less. So therefore, to find the probability of a single order being greater than that, just take 1 minus 0.693. So the probability that an x, maybe I better define x first, x is equal to the amount of a single order. We're going to use the probability of x greater than 40 is equal to 1 minus 0.691, was it? 0.693. And so about 31% is the correct answer to part A. Part B. Briefly describe the shape of the distribution of single orders supported with appropriate descriptive statistics. Give the mean, the standard deviation, discuss other aspects such as skewness and the number of modes. All right, let's go back and let's go answer all these questions. I'm going to get rid of my frequency distribution. I don't need that anymore, and it just takes up a ton of space. So we can get some information from this table. We've already said that it's right skewed with outliers for sure. The mean is, let's call that x bar, let's call it the mean, is 38.5822. The standard deviation, just copying that from my output, is 41.8523. And the skewness, as we indicated earlier, was 5. The kurtosis is 51. Now it says something about discuss the number of modes. Well, our histogram really only showed a single mode. Let me go draw another histogram. Let's get only the histogram this time. I probably shouldn't have deleted that. We're going to bring order amount in. And so, you know, sure enough, we just have a single mode. And it looks like that's it for part B. Part C. The company expects to receive 1,000 orders tomorrow, following the same distribution as in orders.save. Consider the random variable the total amount of revenue from 1,000 orders tomorrow. Okay, describe the shape of the distribution of total order amount, give its mean, standard deviation, and its name. Okay, so part C is going to be this. So let t hat, so we'll call that t hat, not that, be the amount from order 1 plus the amount from order 2 plus ... plus the order from order 1000. And so again, this is the total amount of 1000 orders. So the question is, what is the mean, the standard deviation, and the shape? Well, the mean of this distribution, so E at t hat, will be equal to n times the mean. So this will be 1,000 times the mean that we found up here. What is the standard deviation? Well, remember from chapter 8 that the standard deviation is sigma times the square root of n. So this is going to be sigma sub x times the square root of 1,000. So there's your standard deviation. And what is the shape? Shape is normal, or let's just say approximately normal, from the central limit theorem. So as a little review of where that's coming from, let's go back to the course packet, and let's go back to somewhere around page 135 or so. So this is the summary of the most important results from chapter 8. So we use this result to find the mean of t hat, this result to find the standard deviation, and then here's the result that gets us to normality, the central limit theorem. So for any population distribution, in this case we have one that's right skewed with outliers, the sampling distribution of t hat's approximately normal as long as n is sufficiently large. Well, n's fairly large here, and I'm going to stand by that it's approximately normal at least. Could even be more than just approximately normal, but it's certainly approximately normal. Part D, estimate the probability of having a great day tomorrow where the total revenue exceeds 40,000 euros. So the way we've been writing this is, what is the probability that t hat is greater than 40,000? And we can do this one entirely in Excel. I probably should be drawing this, but to do it entirely in Excel, we'll use norm dist. Actually, we need 1 minus norm dist since this is a greater than problem. So we need the value, which is 40,000. We now need the mean. So the mean is in C7. We need the standard deviation, which is in C8. And we want to know whether it's a cumulative distribution or not. It is cumulative, so we'll say true. So the answer is that there's about a 14% chance that we have a total amount of more than $40,000 tomorrow. Part E, estimate the probability of generating between 38 and 40,000 euros in total tomorrow. So the way we've been writing this is, what's the probability? So it's 38k less than t hat less than 40k. So let's find the probability that we have less than 40. So 40,000. The mean, again, is C7. The standard deviation is C8. And we'll say true. But that also includes orders less than 38,000. So now we need to subtract off the probability of getting 38,000 or less. So norm dist, 38,000. The mean, again, is C7. The standard deviation is C8. True. So the difference between those two gives us the probability, about 53%. Part F, estimate the probability that the average order amount will be between 35 and 37. So part F, well, let's get the E of x bar, where x bar is the mean. Maybe I should define x bar first. X bar is equal to t hat over 1,000. And the mean of x bar will simply be the mean of x. So C7. Actually, yeah, that's right. And then the standard deviation, x bar, remember, is sigma over root n. So that's going to be C5 divide by the square root of n. So divide by the square root of 1,000, and you get 1.32 something or other. So this part is saying what is the probability that the average order amount is between 35 and 37. So the probability that 35 is less than x bar is less than 37. It's going to be just like the problem we just did. So let's take norm dist. So let's find the probability that the mean is less than 37. Well, it's 37, and the mean is C13. The standard deviation is C14, true. Less the chance that we are 35 or less, so norm dist 35, C13, C14, true. So you can see the formula up here. And so that's about 11%. There's an 11% chance that we have a mean order amount of between $35 and $37 or euros. Part G. So now suppose that 10% of all orders will be returned and that 5% of the non-returned orders will result in bad debt. Suppose further that the company makes 40% profit on every euro it receives. Find the mean and the standard deviation of the total amount of profit after accounting for returned orders, bad debt, and the margin from the 1,000 orders tomorrow. Hint, think of it as a linear transformation. So let's say that y is equal to the order amount after, bad debt, returns, and margin. So what is y? Well, y is going to be, we're going to take the number of orders times 0.9. Okay, so 90% of all orders are not going to be returned. Now, of those, we're going to have 95% of them where we actually get paid. And then of that, we get 40%. And so I shouldn't say order amount. Let's call this profit. All right, so in essence, well, let's go do that multiplication. So 0.9 times 0.95 times 0.4. So that should be I forgot a multiplication sign in there. So we get in other words, we get to keep about 34 cents on every euro that is ordered. So really x is equal to 0.342 times x. So what are we asked for? Find the mean, standard deviation, and the total amount of profit after accounting for all that stuff from the 1,000 orders tomorrow. So the profit from so let's go back to the course packet. It says to think of this as a linear combination. So we had some formulas on rescaling data. So if you have a linear transformation, y is equal to some constant times a number, then the mean is just the old mean put through the same transformation. Standard deviation is, well, use the multiplicative constant. So let's go, we can find this as we have mean of y will be 0.342 times the mean of x. So the mean of x is up here. So if we get 38 euros for every order, that's going to result in profit of 13 euros. SD of y will be, well, we're going to take 0.342 times the standard deviation of x. And so that's our standard deviation. Now we have to do this for the total orders tomorrow. So let's just take for total orders, the mean is going to be 1,000 times what we get from one order. The standard deviation will be this standard deviation times the square root of 1,000. And I think that's all we have to do. And then that's it for this question.